It's 4 o'clock. Let's get started. So I'm assuming most people are here because I'm going to talk about the test, right? Everyone wants to do really well on the test? No one? Okay, well then I guess we won't talk about it. So I do have the test with me. I will not show you, but I will sell it to the highest bidder. You don't want it? No? I got to be careful because there's a camera right there. I don't want to put it on the camera. So there are three questions, three problems I should say. And like last test, a lot of those problems have different parts. So I'll try to be giving you hints of what to study, what sections to study, as well as hints of which type of problems you should know. But as far as example problems, they're pretty, if you know how to do the example problems from your chapter homework, you should be, well, okay, if you know conceptually how those problems work, you should be fairly set on the test as a whole. But I'm going to start by just telling you which sections in the chapters that I think are important, which unfortunately is almost all of them, but there are some that you can ignore. Well, I'm not going to say that. They kind of cover other things in the other sections of the chapter, so that's why I'm saying they're not as important, because if you read those sections, you should be okay. But chapter 5, 5.1 just kind of introduces you to force, and so that's not important. All the Newton's laws sections are important, mainly because they introduce you to concepts that are important. 5.3 just talks about mass. If you don't know what mass is, go to that section. Otherwise, move on. Gravitational force, 5.5 is important. 5.6, third Newton law. Then 5.7. I feel like 5.7 is more important than the rest of chapter 5. If you understand basically the Newton's laws, you have a good idea of Newton's laws. 5.7 is all you want to study in chapter 5. That's if you have a really good understanding of everything else in chapter 5. The reason why chapter 5 is important is it goes over, chapter 5, section 7. Chapter 5, section 7 is important. It's called Analysis Models Using Newton's Second Law, because it goes over a lot of different examples. A lot of different examples that could resemble things on the test. I hope I'm not giving anything away. So that section I feel like would be important to go over, and you would understand a lot of the force, Newton's second law, which is a pretty important law in physics. So 5.7 is important, and then 5.8 goes over friction. So I will confirm that there are frictional questions on the test. So 5.8 would be important as well. Okay. Now chapter 6. Chapter 6, most of the things in chapter 6 are important just because all the sections are kind of related. Uniform circular motion is important. Then the next one is 6.2, non-uniform. So if you have a uniform circle, but you have another force besides centripetal force acting on it, that is something else that might be important. Wink, wink. Come on. Okay, so that's 6.2. 6.3, motion in accelerated frames. That is important as well. So basically if you see something happening and like someone is in a cart on a train or something and they're moving and you see something, it looks different to you because you've seen the train cart move as well. They're experiencing that. They don't see that, but they see things respond to that. So inertial frame of references, motion and accelerated frames. It's important. And then I think the last one was resistive forces, but I can't. Where is it? Oh, 6.4. Yeah, motion in the presence of resistive forces. So that's. Actually, don't remember a question about that. Don't quote me on. Don't. I don't want to look at it right now because the camera will pick it up and see everything on the test. But I don't remember resistive forces being on the test. But friction is, which is a resistive force. Things about springs are there, which is also it's a restorative force. But things like air friction or air resistance. Oh, I take that back. There are some questions about air resistance. So 6.4 will be important as well. Okay, then 7. So basically every section in chapter 6 is important. Okay, 7. 7.1 might not be necessary. It's just system and environments. It kind of goes over conceptual things. If you're having issues with chapter 7, start there. Otherwise, you can jump to work. So work done by a constant force. That's section 2. That's important. Section 3 is important. Introduces scalar product of 2 vectors, or the dot product, which is definitely on the test. So be aware of that. Dot product. I don't think I'm giving away too much. If everyone in here gets an A, I'm okay with it. Kinetic energy and work kinetic energy theorem. So energy is definitely on the test, both kinetic and potential, which is 7.6. So 7.5 is kinetic, 7.6 is potential. And conservative and non-conservative forces are definitely on the test. Relationship between conservative forces and potential energy. Yes, that's on the test as well. So every section of chapter 7 as well is on the test. So there are a few sections here and there that aren't on the test, but I guess you'll have to study everything. I will give you some more hints though. So before I go into that, the test at the beginning, it tells you what you can use: open book, open notes, open phone, as long as it's airplane mode, open calculator, as long as it's not pre-programmed. And if you know how to do that, that's impressive. Yeah. It means if you don't know, then you probably won't do it. But pre-programmed, it's what I did in 8th grade, and I basically set up equations where all I would have to do is type in the variables, like height, base. I get the area of a triangle without having to do any math. So don't pre-program all the equations for kinematic motion or something else. Do it by hand, write it out. You should be fine. And then we only have 1 test this time. Remember how last time I said we had 2 tests? We had a white and a yellow. There were 2 tests. They were just exactly the same. This time we have 1 test, but there's still a twist. So when you come on Friday, you'll be like, whoa, what's going on? So yeah, we still have something up our sleeve. But it's 1 test. So there's only 1 test. Everyone will be doing the exact same test. Just know that when you come, we'll be doing stuff slightly different. Okay, here are a few hints about the test. A few things that I didn't specifically say. Sig figs. I graded a test. No one got 100 on the last test. The highest grade was 99%. That person missed a sig fig question. They got everything right except the sig fig question. And that was actually fairly common. It was actually interesting to see that people did really well on like the conceptual parts and answering just random parts. But then when it came to sig figs, they did it right. They just didn't do the sig fig right. So after you're done with the test, go back through, make sure that you've done the sig figs right. That's like my first hint. There will be sig fig things on the test. So make sure that you go back through and check those. Okay, and dating back to the first recitation, make sure you know how to set the problems up. Conceptualize, categorize, analyze, finalize. Those are the 4 steps that you need to do. If you don't remember that, it's in your book. But it's conceptualize, categorize, analyze, finalize. If you follow those steps, you should be able to do most of the problems. Okay, this is a big one. Know how to solve problems symbolically. This was also in one of your problems on the last test. You still have to know how to solve something symbolically. Question 1, that's a symbolic question. You have to solve it symbolically. I will not tell you anything else about it, but you will have to solve it symbolically. So know how to do that. Know different types of systems, so pulley systems or any other sorts of systems that have balances of forces. Those are very important. Know how to draw free body diagrams. There are several questions that specifically ask you to draw a free body diagram. So make sure you know how to draw free body diagrams. And on top of that, remember all forces, every single force you can think of, and remember which direction they're going. If it's opposing that force, you subtract it. If it's going perpendicular to that force, you don't have to worry about it because it doesn't affect it at all. So just know conceptually how you handle the forces, how they add, how they subtract, how they go together. Okay, so now I'm going to tell you exactly how many problems there are and what their points systems are worth. So there are 3 problems, like I already said. Problem 1 has 5 problems in it, and one of those problems has 2 parts. So problem 1, 1.1 is worth 20 points. 1.2 is worth 10 points. This is going to add up to 100. That's the one that's 2 parts. So problem 1.2 is the A and the B part. 1.3 is 20 points, 1.4 is 10 points, 1.5 is 10 points. So the very first question is all written, and that adds up to 70. 70 points will be written. Now the next 2 questions are both 5 questions, and they're all, it was like that always, sometimes, never thing. Remember that one from the first test? That's going to be the first 5 questions, always, sometimes, never. And the next 5 are going to be A, B, C, D, E, so 5 choices. And first one's worth 10 points, but remember, if you miss it, you get -1. The second one is 4 points for each problem. You miss one, it's -1 as well. So you have the possibility of getting -5 in each section, but when I grade it, I just put a 0 if you have a negative, because I'm not going to subtract points from elsewhere in your test. But it's very similarly set up. Just know that you have less always, sometimes, never questions, which I think got a lot of people. I think you have comparable of how many, like, fill in the blank or write out your problem questions. I will say that this one, the first test took me about 15 minutes to do. This one took me somewhere between 20 and 30. And I don't know if I was focusing the whole time, but that's how long it took. Yeah, not sure how much else I want to say about it. I did have some questions. Don't be afraid to ask questions while you're doing the test. In fact, we might announce things at the beginning because I picked up stuff during the test that he might have messed up. Not messed up, but just needed clarification. So we might say something at the beginning of the test to clarify those things that I needed clarification with. But other than that, should be hopefully straightforward. Yeah? If you're done with your test, you go to the front and wait. If you have a question, just raise your hand. If you're in the middle, it's kind of hard. So yeah, you might have to leave your row to come ask us a question. But if you're on the sides, it might be easier. But that won't be guaranteed for anyone. So yeah, if you really need a question answered, just come to where one of the proctors are. There should be 5 proctors, or 4 proctors. I don't think Jeff will be there, right? Okay, so 4 proctors, and then Jason. So 5 total people that can answer your questions. Actually, Jason will just be up there on the computer probably, and his slaves will be the proctors. Okay, are there any other questions on the test? I tried to give you as much information as I could without actually giving you what the questions are. Okay, I know you guys will do amazing. It's super easy test. I'll just say that. It's super easy. It's super easy for me, so it's got to be super easy for you too, right? I just want to make sure there's nothing else I can add. I think I covered it all. Any other questions for the test? Okay. Yeah, I can't tell you anything else without actually giving you a problem. So now we're going to go over all 10 of the problems from the homework. There are 10 problems. There's a couple tricky ones, a couple that you might not know exactly how to do. One of them required me like an extra 5 minutes for me to do, and I was like, dang it. So I usually do these problems in less than 5 minutes. But we'll start with problem 1. So problem 1, we will put that up. Problem 1. So problem 1, and if you're just here for the test part, you can get out of here. But if you still need help with the homework part. Okay, so problem 1 talks about a raindrop. Raindrop falling at a constant speed. When you hear constant speed, you should instantly think forces are balanced. Zero acceleration, constant speed. Okay, so problem 1 gives you the weight of a mass, the mass of a raindrop, and it's vertically falling, constant speed, under the influence of gravity, and air resistance. So, as it falls 100 meters, what is the work done on the raindrop? Okay, well, the only equation you need to know for this is work equals force times distance. You are given a distance. You should know the force. And it specifically asked the work done on the raindrop by the gravitational force. So, boom, part A. Now, part B, what is the work done on the raindrop by air resistance? And I already told you the sum of the forces equals 0. So you should be able to, from that, know what the air resistance force is. It has to be perfectly balanced. So knowing this, you already know air resistance force, just the other direction. Any questions on problem 1? Okay, problem 2. Okay. Problem 2. Find the scalar product of the vectors in the figure below. Ooh, that was one of the ones I asked you guys that you needed to know. So that was chapter, 7? Yeah, 7.3. So A dot B equals, and remember there's 2 ways to represent this. You can dot each I hat, J hat, K hat. You can times those together and add them. Or you can take the magnitude of A and B and times it by the cosine theta between the 2 vectors. That is equation 7.2. Equation 7.2. So we know the magnitude of both of them. It tells us. So for everyone, the centimeters per second is the same. Make sure you realize that that is centimeters per second, not meters per second. And you have it's in red, so everyone gets a different one, but you have the force given. Gives you the angle with respect to the positive y for force, and then it gives you the other one. Anyway, you have to do some subtraction in math to find out what the angle between them is. And that will get you theta. You already know A and B, and 2 is done. So that's all you need to do. Any questions on that one? Yeah?
Is that in watts?
Yes, it is. So it's joules per second, which is watts. Any other questions? Okay. We're just going to cruise through these. Question 3. Asks, force acting on a particle varies as shown in the figure. And it has a drawing. Should be the same for everyone. Imagine if that's symmetrical. base Hooke's law. That's awesome. Everyone remember Hooke's law? Force equal negative kx. Okay, spring constant, x is the displacement. Spring stretch is 2.50 centimeters. Okay, so with some mass 1, you get a displacement of x1. Then it's saying you put a different mass on, you get a displacement. You put F2 on, you get a displacement of x2. So if we were to look at this Hooke's law, so the base Hooke's law, it would show mg negative k x1 into g equals negative k x2. So both of these relationships hold. So k is a constant, g is a constant. You can solve for one. There's several ways you can do this problem. You can solve for one, you can solve for k, plug into k, or you can just divide the equations because they are related. G's cancel, k's cancel, and it wants you to solve for x2. So that is one way to do it. And the other way, you just have to plug stuff into things. So you have k as an unknown, so you know m1, you know m2, you know x1. So you can solve for k here, plug it up there, and same thing. Or you can just divide the equations. Yeah. Nope, so this equal sign still holds. So it would be m1 over m2 equals k1. Does that make sense? Not everyone's done division of equations before, so that's the gist of it. Divide the equations, all the constants, well, everything that's equal will cancel out, and you're left with these ratios. Now, the part B, the main thing you need to know is you can solve for k, so you can get a physical value for k, and it asks for the work, which I don't know if I did it this way. I'm assuming everyone did it this way. But you plug it into 1/2 kx squared, and that will give you the work for energy in joules, which is work, for the external force. So how much work must an external agent do to stretch the same spring? So now it's asking you, if I was standing there and there's no mass on it, so you can't use force times distance because you no longer have a mass. You no longer know what that questions? Hopefully I gave you enough information to solve that one. I don't like doing all of them. I like leaving some room. Okay. 7. Okay. 7. A 170 Newton child. Okay, that's going to be different for everyone. So a child of some force in a swing that is attached to ropes. Okay, this one is fairly simple. So there's 3 different situations that I'm talking about. My child walks so fast. So you have one that's this way, and you have one that's 45. No, what's that? At some angle. And then you have one that's straight down. Okay, so I know this one was shown today, class. So depending on if you choose gravity or down to be positive or negative, you may have a negative sign here. Depending on if you have gravity to be negative or not. But potential energy can't be negative, so if you have a negative sign in front, just know that gravity has to be negative as well. I'm going to choose to say no, it will be negative. So no negative in front. Okay, so you have a certain position down here. I guess this length. And it's saying potential energy. That must also be L. Pendulum swings around. So L is your H, mg. So mgl is your potential energy because L is your height. It's not saying your height above the ground, it's saying until all the potential energy goes away. And at position 0, which spoilers, this is part C, you have 0 potential energy, it's all kinetic energy, and then it comes back up all the way over here, which is completely potential energy, no kinetic energy, and just keeps trading off. So it goes back and forth. So up here, you have all potential energy, no kinetic energy. And down here, you have all kinetic, no potential. And part B is in the middle. So this is part B. Sorry, I said 0. I get that one way. Oh well. And it says you have an angle of 34 degrees. From where? From with the vertical. Theta. So now you need to figure out, this is simple geometry, I'm going to do this for you, but now the height is here. There's several ways to do this. You can find out what this chunk of the vertical is, then subtract that from the total L, and you get this chunk right here, which is your new H. Yeah. Yeah, so this is your H. H. So that's here, here, H. Figure out this piece right here. That's your H. Plug it in. Equation. Mass and gravity do not change unless we have one of those cool tilting pendulums that we can lap. Oh, no. Please not such a pendulum. H, H. Here, H is obviously 0. That's why it is your potential energy. Any questions on that one? Okay. Problem 8. Ooh, this was a fun one. This is the one that took me slightly longer than it should have. This is probably a lot of people have questions on this one. Okay. So I was doing my integral with the 4 assumptions, so that's why. Okay. So this one, it says you have 2 different ways for a particle to move from one location to the other. I'll draw this. You have particle here. It says what if it goes here and then up, or here and then over. So this is your starting position. It's your ending position. Some value of xy. Gives you xy. I'm this one, you need to calculate the work done by force. Well, let's go back to our handy integral. I'm going to call it dr because now we have a vector that has two components, as I hat, j hat. It's not just one dimensional. So we have dr. Now, an interesting thing about this is you need to break it up into components. So you're going to take the x hat, or the I hat, fx dx, solve integral fy dy, f sub x times dx plus f sub y times dy. And remember dy is the little change that happens in the y direction, dx is the little change that happens in the x direction. So we have O, A, B, C. So I will do part A for you, and then I will not do part B for you. That's what you will do. But hopefully me doing part A will show you how to do part B. Okay, so part A, we're traveling from the origin to A over here. So let's start plugging stuff in. We're going to make work O origin A equals integral. Okay, so mine, oh, it should be the same for everyone. So the force equation is 2y I hat plus x squared j hat. So so the only things that change are your x and y values for everything. So I will leave x and y symbolic so that you can just plug them in. See. Okay, so fx, what is the f sub x in this equation? Oh, that's the j hat, that's the y. This one, yeah, 2y. So we have 2y dx plus, what's the fy? sign of the force. Slope. Okay, so that should cover all 10 problems. Are there any other questions? All right, get out of here. Study for the test. Get A's. I know all you will. I'm still selling this test up here. If anyone wants it. Highest bidder.